Welcome to the deep dive. Today we're going to try and cut through the noise, give you a really clear, concise understanding of a concept that's, well, pretty crucial in modern software architecture: command query responsibility segregation, CQRS for short.
Right.
Our goal here for this deep dive is basically to distill the most important insights, maybe give you those aha moments, and perhaps even some surprising facts about CQRS, especially, how it fits into the whole world of microservices. We've pulled together a pretty rich stack of expert research to guide us.
Yeah, and I think what's often overlooked, or maybe the fundamental problem CQRS really forces us to look at, is how those traditional sort of single model approaches often lead to compromises.
Hmm.
You end up with a database schema that's maybe terrible for reads, or it's terrible for writes, or sometimes, honestly, it's bad at both, because you're trying to optimize for two fundamentally opposing concerns.
Right. Squeezing two different jobs into one tool.
Exactly.
Mhm.
And CQRS just steps in by forcing us to, well, address that trade-off head on.
Okay, let's unpack that a bit. So, at its core, CQRS, and it's a pattern championed by folks like Greg Young and Udi Dahan, right?
That's right. Key figures.
It separates the responsibilities of reading data, what we call queries, from modifying data, our commands. It's kind of like designing a system where you have these distinct, highly optimized pathways for different tasks.
Hmm.
I like the analogy of, say, a busy operations center. You wouldn't have the same team handling critical incoming alerts and generating complex historical reports at the same time, would you?
No, definitely not.
You'd have one team optimized for that rapid transactional intake and another completely separate team for the sophisticated analytical reporting. That core separation. That's basically CQRS in a nutshell.
Precisely. Yeah. And in software terms, commands represent an intent to change the system state. Things like place order, register user, or update inventory. Actions.
Got it.
Queries, on the other hand, they're purely about asking what is the current state.
Mm-hmm.
Without any side effects, no changes allowed. Just asking. And the real power comes because this separation often leads to using distinct data models,
Mm-hmm.
sometimes even different storage systems, each one perfectly tailored to its specific job.
Okay, and you mentioned this earlier, but it gets even more powerful when you pair CQRS with something like event sourcing. That seems to come up a lot. What's the synergy there? Why is that pairing so compelling?
Ah, yes. That's where the magic really happens, I think. Instead of just storing the current state of data, like what the data looks like right now.
Right, the snapshot.
Exactly. Event sourcing records every single change as this immutable sequence of events.
Hmm.
So an order isn't just updated, it's an order placed event, then maybe an order quantity adjusted event, maybe a payment received event, and so on.
Like a logbook for everything that happened.
Precisely. And this pairing gives you a complete auditable history of everything that's ever happened to that piece of data, which is just invaluable for traceability, for debugging, and critically, for even rebuilding the system state from scratch if you need to.
Wow, okay. So, with these tailored models and this really rich event history, how much more efficient does scalability actually become? Is it just a linear improvement, or does it unlock completely new ways of scaling that maybe weren't possible before?
Oh, it's pretty transformative, I'd say. This independent optimization means you can scale your read operations and your write operations completely separately, based purely on demand.
Okay, give me an example.
All right. So imagine you have a denormalized read model. Maybe it's specifically designed for lightning-fast queries. That means we might flatten out complex relationships, pre-join data, tailor the schema directly to exactly what the user interface needs.
So you're sacrificing maybe write model purity for just blazing read speed.
Exactly. You optimize aggressively for reads. Now, let's say you have a marketing campaign that suddenly doubles user views on your site. People are just looking at stuff, not buying yet.
Right, read heavy.
Super read heavy. With CQRS, you can scale only your query infrastructure, maybe add more read replicas, beef up the cache without touching or impacting your critical write paths at all. The part that takes orders stays stable.
That makes a lot of sense. And I guess that dramatically simplifies the individual data models too, doesn't it? Instead of one often bloated model trying to be everything to everyone.
Absolutely, you get these lean, focused models. And that, in turn, brings tremendous flexibility. It really allows you to use diverse storage solutions.
You mean like different types of databases?
Exactly. For example, you might use a traditional relational database like PostgreSQL for your writes, where you need that strict consistency, the transactions. But then for reads, maybe you use a NoSQL database like MongoDB or Elasticsearch for super fast lookups or text searching.
Okay, so mixing and matching databases based on the job.
Precisely. That strategy even has a name: Polyglot persistence. It's all about picking the absolute best database technology for each specific data need, rather than trying to force a one-size-fits-all approach onto everything. It just frees you up.
Yeah.
Choose the right tool for the right job.
And circling back to that event sourcing integration we talked about,
Mm,
you mentioned rebuilding state. That means you can literally replay events to reconstruct how things are, right?
Yep.
That seems like a massive win for recovery, but also just for understanding how your system got into a certain state, and surely for maintainability, too.
It truly is a huge win. By separating these concerns so clearly, both development and, maybe more importantly, ongoing maintenance become much simpler, especially as systems get complex and inevitably evolve over time.
Right.
Which, naturally leads us to ask, how does this powerful pattern really play out in the world of something like microservices?
Yeah, that seems like the perfect fit, doesn't it? Because when you think about microservices, you're already talking about these independent, smaller services. They communicate via APIs, and each one often handles pretty diverse workloads. So when you apply CQRS within a microservice, you're essentially splitting its own data handling into those specialized command and query models we've been discussing.
Right. A great example could be, say, a microservice that manages user profiles.
Okay.
It might use, let's say, a relational database for its write model that ensures strict transactional consistency when someone updates their email or password. Can't mess that up.
Critical data, yeah.
But for the read model, which maybe just powers profile lookups for potentially millions of users across the platform,
Lots of reads there.
exactly. You could use a highly denormalized NoSQL store,
Mm.
maybe something like Redis or Cassandra, optimized purely for super quick retrieval. This just simplifies the logic within that single microservice dramatically. It only has to do one thing well on each side.
Okay, so following that example, if a social media platform suddenly has a surge in people viewing profiles, maybe something went viral, that read-heavy part of the user profile service can scale its query infrastructure way up
Independently.
independently, spin up more read replicas, whatever it needs. And it doesn't affect the right side at all. People can still update their profiles just fine. That kind of granular scaling must be invaluable in cloud-native setups where resources are elastic.
Absolutely essential. And crucially, this aligns perfectly with event-driven architectures, which are so common with microservices. Remember those events we talked about?
From event sourcing, yeah.
So commands generate events, which get stored, typically in an event store.
Mm.
Then other microservices, or even just the query side of the same microservice, can subscribe to these events.
Oh, okay.
And listening to those events is how they build and update those optimized read models we discussed. It ensures what we call eventual consistency.
Eventual consistency, that sounds potentially problematic. Does it mean data is out of sync?
It can be a challenge, but it's usually manageable.
Yeah.
It doesn't mean eventually, like maybe next week. It means there's typically a very short, often sub-second, delay between the write happening and the read model reflecting it.
Okay.
Designers just need to account for that. Maybe by showing a little processing spinner for a moment or displaying a subtle timestamp until the read model fully updates. But the huge benefit is that this enables microservices to publish events, which fosters truly loose coupling and asynchronous communication between services. They don't need direct calls. They just react to events.
Right. That loose coupling is key for microservices. So, from a performance angle then, it means the read models can be heavily denormalized, maybe cached aggressively for complex queries, slashing user-facing latency.
Exactly. Well, your write models can just focus solely on maintaining that strict consistency and validating the incoming data without the burden of also needing to be fast for every conceivable query.
It just makes the individual services smaller, more focused, really helps them adhere to that single responsibility principle people talk about.
It does. So, what's the so what here? Why is CQRS actually so fundamentally crucial for microservices, beyond just being a neat pattern?
Good question. What's the bottom line?
Well, I think it's really about gracefully addressing the inherent complexities you find in distributed, data-intensive systems. Microservices, almost by definition, often juggle wildly diverse workloads. You might have one service doing real-time analytics dashboards needing fast reads, and another handling critical transactional updates needing absolute reliability.
Very different needs.
Totally different. CQRS lets you tailor the read and write models for each specific need, optimizing both query speed and write reliability, often simultaneously within the same logical service boundary.
And it also seems to perfectly align with that whole cloud-native need for elastic infrastructure. When you're in the cloud, you want to scale resources just where they're needed, right?
Precisely. CQRS enables that independent scaling for different parts of your system scale, read separately from writes. Plus, when you add event sourcing into the mix, it builds incredible resilience. You can replay those events, reconstruct state if something goes wrong. It helps ensure your data remains consistent and recoverable.
Yeah, that recovery aspect sounds really powerful.
And don't forget the asynchronous communication facilitated by events. It drastically reduces dependencies between microservices, leading to much looser coupling. That's just vital for systems where different components need to evolve independently without constantly breaking each other.
Right, you avoid those tight-knit dependencies that make changes so hard.
Exactly. And for diverse use cases, CQRS lets you create customized read models for totally different types of clients. Maybe one for a web app, another optimized for a mobile app, maybe a third for some internal API.
Tailoring the view for each context.
Enhancing the user experience for each one, specifically tailored to their needs. So ultimately, by separating that command and query logic, it significantly simplifies the development and the evolution of services, as requirements inevitably change over time, which they always do.
Okay, this all sounds incredibly powerful, but there's always a trade-off. We need to be clear about the practical considerations too. It's not a silver bullet, right?
Oh, absolutely not. And it's important to be upfront about that. CQRS does introduce additional complexity. There's no getting around it.
Like what specifically?
Well, you're talking about maintaining separate models, potentially different database schemas. You need synchronization mechanisms to keep the read side updated from the write side. And you might well be running multiple databases or data stores.
So it's probably not for every single situation.
Definitely not.
Yeah.
It's really best suited for systems where there's a significant disparity between the read and write workloads, or where the query complexity is very high. If your system's needs are fairly balanced, pretty simple CRU-like operations.
CR read being create, read, update, delete, the standard stuff.
Exactly.
Yeah.
If that's mostly what you do, the added overhead of CQRS might genuinely outweigh the benefits. You'd be adding complexity for no real gain.
That makes sense. And you mentioned eventual consistency earlier as a benefit for loose coupling, but it's also a challenge, isn't it?
It is. It's probably one of the main challenges people grapple with because the read and write models are often synchronized asynchronously. Using those events we talked about, there can be that slight lag.
The one you said was manageable?
Usually manageable, yes, but it requires careful thought, especially in user-facing applications. If a user performs an action, say, adds an item to a cart, they usually expect to see it reflected immediately.
Right. Instantly.
So you might need to design the UI carefully, maybe show a temporary processing state, or use clever techniques like optimistic UI updates locally while the backend catches up, just to manage that user experience smoothly. It needs conscious design.
Okay. And what about the development side? Is it harder to build systems this way?
There's definitely a learning curve and, yes, a development overhead. Implementing CQRS well often demands expertise in event-driven architectures. You need to understand message brokers, things like Kafka or RabbitMQ, to move those events around reliably and at scale.
So specialized skills are helpful.
They are. Plus, just the practicalities of maintaining potentially separate read and write stores that can increase infrastructure costs, more databases, more monitoring, more operational complexity. So it always needs a solid cost-benefit analysis before you dive in.
It really underlines the point. Know when to use it. Crucially, CQRS is not always necessary.
Exactly. For simple microservices, maybe ones with pretty balanced read-write loads, a traditional CRU model might be perfectly sufficient. You avoid all that added complexity. Knowing when not to use CQRS is probably just as important as knowing when to apply it.
Okay, so let's say you've done the analysis and CQRS is the right fit for your system, or at least part of it. How does an implementation typically, flow? What are the moving parts?
Sure. Let's walk through a typical flow. On the command side, a microservice receives a command. Let's say it's create order coming in via an API call.
Okay.
First, it validates the request. Is the data okay? Does the user have permission? Then, it updates its write database, the source of truth. And importantly, if it's using event sourcing, it then generates one or more events, like order created, maybe with all the order details, and stores them in an event store.
So command, validate, update, write, DB, generate events.
That's the command side loop, essentially.
Yeah.
Then you have the query side. Often, this is a separate process or even part of the same service, but logically distinct. Its job is to build and maintain the read model.
The optimized one.
The optimized one. It subscribes to those events generated by the command side. It listens for order created, order updated, etc. When it sees an event it cares about, it updates its own read model, creating those highly optimized views tailored for specific queries like get order summary or list resend orders.
And these optimized views might live in a completely different database.
Often, yes. Read optimized database or maybe your distributed cache, and the synchronization between the two sides. That's typically handled by propagating those events via a message broker, Kafka, RabbitMQ, Azure Service Bus, something like that. It reliably delivers the events from the write side to the query side subscribers, ensuring that eventual consistency.
Gotcha. Are there tools or frameworks that help with all this? It sounds like a lot to wire up manually.
Oh, definitely. There are frameworks that can help manage a lot of this complexity. Things like Axon Framework in the Java world. There's Event Store DB, which is both an event store and has client libraries. Or you can use components from larger ecosystems like Spring Cloud Stream or In-Service Bus. They handle a lot of the boilerplate for event publishing, subscribing, and sometimes even managing the read model projections for you.
Right, so you're not building everything from absolute scratch.
Hopefully not, no. These
Gotcha.
tools can really accelerate development once you understand the core concepts.
Okay, so let's try and bring this all together then. What we've really unpacked today is that CQRS, Command Query Responsibility Segregation, is a seriously powerful design pattern, especially relevant for modern, complex systems, and particularly when you're building with microservices.
Yeah, I think that's fair to say.
It seems it truly enhances performance, scalability, flexibility, and even maintainability, all by intelligently separating the way you handle reads and writes. It solves fundamental problems that trying to use a single monolithic approach often just can't.
Absolutely. And our hope with this deep dive was to give you a clear, maybe more nuanced understanding of this, well, fairly sophisticated architectural pattern, allowing you to connect the dots between related concepts like event sourcing, that polyglot persistence idea, and just sound microservices design in general.
Giving you the context to really see how they all play together.
Exactly, understanding their interplay.
All right, so as we wrap up, here's maybe a thought to ponder as you go about your day. Given this constant increase in complexity, the relentless demands for scalability in today's distributed systems, how might architectural patterns like CQRS evolve even further?
Interesting question.
How might they change to maybe minimize some of that inherent complexity we discussed while still maximizing the benefits? Are we pushing the boundaries of what's possible, especially in these cloud-native applications? Something to think about.
Definitely food for thought. Thanks for joining us on this deep dive, everyone. Keep that curiosity alive.